Students, in my previous notes I have discussed about the principle of mathematical induction. Whatever the question we have discussed, I would like to discuss once again so that it will be clear to you. In fact, I started with the particular statement. See, what is called a statement? A statement is a kind of sentence which can be judged whether it is true or false. Suppose I say 6 is divisible by 2. Patna is the capital of Bihar. 2 is only the even prime number. (121) is a prime number. So here we have some sentences. We are going to judge whether they are correct or not. When you talk about this, it is a true statement. When you judge about this, it is also true statement. When you talk about this, it is also true statement. But when you talk about 121, it is a false statement because 121 is not a prime number. It is divisible by 11. So these kind of these sentences which we are going to judge are called statement. And all such statement which are involving mathematical relation is called the mathematical statement. And in this topic we are mainly mean to prove the mathematical statement by some of the process. And what is that process is called the principle of mathematical induction. Suppose we are talking about Pn is equal to 2 to the power 3n minus 1. When we talk about Pn is equal to 2 to the power 3n minus 1, this is considered as a statement where n always belongs to capital N. Capital N means natural number. So what I am going to tell that this Pn is true for divisibility of 7 means this can be exactly divisible by 7. Let us take n I said is a natural number. When I say n is a natural number, we are bound to take only the natural number so far as the value of n is concerned. Suppose I take first n is equal to 1. Substitute here P1 is equal to what? 2 to the power 3 minus 1 is equal to 7. Is it divisible by 7 or not? Let us take 2. P2, 2 to the power 3 into 2 minus 1. How much it is? It is equal to 2 to the power how much? 6 minus 1. 2 to the power 6 is equal to how much? 64 minus 1 is equal to 63, which is equal to 9 into 7 divisible by 7. Let us take 3 also. P3, 2 to the power 3 into 3 minus 1 is equal to 2 to the power 9 minus 1. Now 4 into 4 into 4 into 4, 2 plus 2 plus 2 plus 2, how much? 8 into 2. So how much it is? 16 into 16 to 56 into 2, and that will be equal to 512. So will it be 512 minus 1? That will be 511. Is it divisible by 7? Yes. 7 7 ja 7 3 ja into 7. So whatever the mathematical statement you have, mathematical relation you have, that we are going to prove that they are divisible by the given number or not. And hence we are going to use that is called principle of mathematical induction. In principle of mathematical induction, what we actually do, we take as Pn is 2, 4, just n is equal to 1 we will take. We take n is equal to 1 and we will prove that this is true for n is equal to 1. After that, this Pn will be true for n is equal to m plus 1, means when you substitute the value of n is equal to m plus 1, when you say n is equal to m, means there are 3 steps. You might have gone through the notes, you might have seen I have written step 1, step 2, step 3. So there are 3 steps. Step 1, when we take n is equal to 1, n is equal to 1 stands that you are going to take any source of natural number, it will be always true. Like this, so far as this particular statement is concerned, we can always say that any value of natural number you take n, it will be always divisible by 7. So that is why we generalize, just we take n is equal to 1, that is the first step, n is equal to m, that is the second step, and third one will be n is equal to m plus 1. For the first statement and second step, we don't have much problem. Where is the problem? Problem arises when you take n is equal to m plus 1. And this is what we have to work out here. So how can we find out that particular values so that it is true for n is equal to m plus 1. So actually today I will discuss 2 type of the questions. One question is like divisibility test, whether it is divisible by any certain number or not. Secondly, we will discuss about the series cases also. I would like to tell you series in the sense that when you study about the AP, GP, and one more topic is the spatial sequence. So when you go in the spatial sequence, you have varieties of the sequences, and those sequences we will able to prove by the mathematical induction. So understood? So let us discuss few questions which are based on this mathematical induction. So your first question is using PMI. What do you mean by PMI? PMI means principle of mathematical induction. Prove that this statement is exactly divisible by 576. Now, here, first of all, we will take let Pn is equal to 5 to the power 2n plus 2 minus 24n minus 25. Now, step 1. In this step, what shall we do? We will take let n is equal to 1. N is equal to 1 means here we will have that where n belongs to capital N. Every cases we are meant to discuss only the natural number in these conditions. In this particular topic, whatever the n is there, n is always meant for the natural number. We are always going for the natural number only. So n is equal to 1. So wherever n you have, there you put it 1. So P1 is equal to 5 to the power 2 into 1 plus 2 minus 24 into 1 minus 25. Will it be 5 to the power 4 minus 24 minus 25, that is 49, and it will be 625 minus 49 is equal to 576, which is exactly divisible by 576. So we can say therefore Pn is true for n is equal to 1. What's about second step? Step 2. As I said, step 2 is taken to granted that it is true for n is equal to m. So we will write let n is equal to m. So therefore Pm is equal to 2 5 to the power 2m plus 2 minus 24 m minus 25. So wherever n was there, that we will put this is value of n as n, and this is found to be true, which is also true for n is equal to m. We are not going to prove anything else, but we will say let 5 to the power 2m plus 2 minus 24m minus 25 is equal to 576 lambda, suppose. And now here you have this value, any of the value you find out, and that we will have to substitute when you are going to prove by n is equal to m plus n, m plus 1, sorry. And therefore here we can say 5 to the power 2m plus 2 can be written as 576 lambda plus 24m plus 25, say equation number 1. And then now we will go for the third step, which is one of the very important part. And let us see how to prove the third step. Step 3. Now we shall have to prove that Pn is true for n is equal to m plus 1. So P m plus 1 is equal to 5 to the power 2 into m plus 1 plus 2 minus 24 m plus 1 minus 25. You try to write by using the exponential rules. You try to write in such a way that you could be able to get that particular number. We can, you see, 5 to the power 2m plus 2 into 5 square. How? When you say bases are same, then powers are added. I said you are going to apply the rule of exponent. And so minus 24m minus 24 minus 25. Here, what can you substitute the value of this? The whole. So therefore we can say here 576 lambda plus 24 m plus 25 minus 24 m, and what is here? Minus 49. So here this is 24 m plus 25, and what happens here? Here will be actually 5 square here, because you are going to substitute there and then 5 square will be retained there. And so you multiply it 25 into 576 lambda plus 25 into 24m plus 25 into 25 minus 24m minus 49, and then 25 into 576, whatever the value I have substituted you can write from 1, plus this and this term you take together, what is common? 24m common, 25 minus 1, and 625 minus 49 will be 576. When you take this one, what will happen? 570, rather one more step I will take, into 576 plus 24m into 24, and it will be lambda here, lambda plus, and plus 576. Now can you tell me this 576, 24 into 24, is it 576? And here is 576. So 576 is common. What is left? 25 lambda plus m plus 1. Now if any expression in the bracket you have where lambda and m is considered as any natural numbers, for any natural number, whatever the number comes in the bracket, it is a multiple of 576. So which is divisible by 576 for all natural number lambda and m. Therefore we can say Pn is true for n is equal to n plus 1. And at last we will write, therefore this is the statement which was given in the form of n. Therefore we can say, therefore Pn is equal to 5 to the power 2n plus 2 minus 24n minus 25 is divisible by 576. So this is the one question. Now let us discuss the second question. Here it is given 10 to the power n plus 3 into 4 to the power n plus 2 plus 5 is divisible by 9. So in this case also we will assume let Pn is equal to 10 to the power n plus 3 into 4 n plus 2 plus 5. So what is your step 1? Step 1, let n is equal to 1. So P1 is equal to 10 to the power 1 plus 3 into 4, 1 plus 2 plus 5. And this will be equal to 10 plus, now 4 cube is equal to 64. So 3 into 64 plus 5. Now 10 plus 5, 15 plus 3 4s are 12, 3 6 are 18, 1 19, and that is equal to 5 2 7 and 0 and 2. Is it not divisible by 9? 9 into 23. So we can say which is divisible by 9. And hence, therefore, Pn is true for n is equal to. Same way we will go for the second case, that n is equal to m, we will take into granted that it is true. So for step 2, Pn is also true for n is equal to m. So therefore Pm is equal to 10 to the power m plus 3 into 4 to the power m plus 2 plus 5. And same way we will assume that this whole expression is divisible by 9. As in the previous case we have taken 576 lambda. In place of lambda you can take any variable. Remember, lambda or whatever the variable you are taking, they are also integer. They are also natural number. So here let 10 to the power m plus 3 into 5 to the power m plus 2 plus 5 is equal to 4 to the power m plus 2 is equal to 9k. Suppose it is 9k, where you know k is also natural number, that you have to keep in mind. So now step, therefore what can you find? Here you find out the value of 10 to the power n is equal to 9k minus 3 into 4 m plus 2 minus 5, say equation 1. Now what is the third step? We have to prove that it is true for step 3. We shall have to prove that Pn is true for n is equal to m plus 1. So wherever n you have to put n is equal to m plus 1. So P m plus 1 is equal to 10 to the power m plus 1 plus 3 into 4 to the power m plus 1 plus 2 and then plus 5. Can we write here 10 to the power m into 10, because when the bases are same, powers are added, so 10 to the power m plus 1 it will come, plus 3 into 4 to the power m into 4 cube plus 5. Same way, bases are same, powers are added, m plus 3, so m plus 3 will be there. I am bound to write in this form because we are going to substitute the value of 10 to the power m from equation number 1. So therefore, this one can be substituted as 9k minus 3 into 4 m to the power, 4 to the power m plus 2 minus 5 into 10 plus 64 into 3, 192 into 4 to the power m plus 5. And now 9k into 10, that means you can directly write 90k, 10 3 is 30 into 4 to the power m into 4 square minus 50. See, look at here, 9k into 10, 90k, 3 into 10, 30, and 4 to the power m into 4 square, and plus 192 into 4 to the power m plus 5. Then 90k, which is directly this multiple of 9, then this m terms you keep together, minus 4 to the power m in the bracket, it will become positive. So 16 3s are 480 minus 192 and minus 50 plus 5 minus 45. So therefore 90k minus 4 to the power m into 10 to 8, 17, 9, 8 and 3, 1, 2 minus 45. Look at here. Is it divisible by 9 or not? 8, 8, 16 plus 2, 18. So you take out 9 as a common factor. 10k minus 9 3s are 27, 9 2s are, and into 4 to the power m minus 5. So what do you notice? Whatever the value of natural number for k and m we substitute, it will always come divisible by. So therefore we can say that is which is divisible by 9 for all natural value of k and m. Therefore Pn is true for n is equal to m plus 1. Therefore 10 to the power m plus 3n plus 3 into 4 to the power n plus 2 plus 5 is divisible by 9. Whatever the question it was given earlier, you can go for that. That is the answer. Now, till now we have discussed about the divisibility. Now I am taking one question where we have to use the series. Look at here. In the series part, the last term, whatever it is given, it is called general term. If it is written already in general term, you don't need to do any more work. But if it is not given, you have to convert into general term. And how to convert into general term, you have to look at it whether it is in AP, GP, and accordingly we have to put it. So therefore, here in this case also we have to say Pn is as this statement. And when you are going to take the first step, in the first step we will take LHS. LHS what we will take? The general cases, and in that general case n is equal to 1 we will put. We will try to compare RHS. In RHS also we have to put as 1 and compare whether they are LHS and RHS are same or not. So look at here. Let Pn is equal to 1 plus 1 by 1 plus 2 plus 1 by 1 plus 2 plus 3 plus 1 by 1 plus 2 plus 3 dot 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 plus n is equal to 2n by n plus 1. Moreover, we can say here as 1 plus 1 by 1 plus 2 plus 1 by 1 plus 2 plus 3 plus dot dot dot. Now let us convert into general term. 1 plus 2 plus 3, it is going to be added till n. You have studied in class 10 AP, and this is term in AP. What is the sum of natural number? The sum of natural number is considered as n into n plus 1 divided by 2. It can be found by taking the formula, Sn formula. S is equal to what? N by 2 into A plus N. A is what? 1. And N is what? Last term is N. So N plus 1, N into N plus 1 by 2. So how it is seen? Sn is equal to N by 2 into A plus An. Now, N by 2 into what is your A? A is your first term 1 and An is your what? N, that is the last term N. What could you write? N into N plus 1 divided by 2. So this is the sum of natural number. So in place of this we can write 1 by N into N plus 1 divided by 2 is equal to 2n by n plus 1. One more step I will write here, that is 1 plus 1 by 1 plus 2 plus 1 by 1 plus 2 plus 3 plus dot 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 plus 2 by n into n plus 1 is equal to 2n by n plus 1. So this is what we call it as the general term of that series, and therefore we will take step 1. We will take LHS, take the general term 2 by n into n plus 1, when n is equal to, let n is equal to 1, so therefore LHS will be equal to how much? 2 by 1 into 1 plus 1. Is it not equal to 2 by 2, that is equal to 1? RHS you take for the same value, 2n by n plus 1, will it be 2 into 1 by 1 plus 1, 2 by 2 is equal to 1. So LHS and RHS both you got same. So therefore you will say LHS is equal to RHS, hence Pn is true for n is equal to 1. Now same way Pn is true for n is equal to m also we will take into granted. So wherever, right from left to right, wherever n is there, we will put the value of n as m. So let us see. Step 2. Pn is true for n is equal to m. Therefore, Pm is equal to 1 plus 1 by 1 plus 2 plus 1 by 1 plus 2 plus 3 plus dot 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 2 by m into m plus 1 is equal to 2m by m plus 1. Take it as equation number 1. What is the third step? Step 3. Now we shall have to prove Pn is true for n is equal to m plus 1. So wherever m is there, you put it m plus 1. So P m plus 1. Now one more thing here, we have to play a trick. You have to write till here, and when you take m plus 1, wherever m is there, in that case m plus 1 we have to write, means we will go one step more. So what shall we write here is 1 plus 1 by 1 plus 2 plus 1 by 1 plus 2 plus 3 plus dot 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 plus, I'm just leaving one step here, I'm just going straight forward to 2 by, in place of m plus 1 and m plus 1 plus 1 is equal to 2 m plus 1 divided by m plus 1 plus 1. Remember one thing, this is the last step. What is last but one step? One is less. So what is the last step will be, last but one step will be 2 by m into m plus 1. And this is the trick you have to apply in such cases. Means you have to write till here and one more step, that is your m plus 1th term. And now what is the purpose of writing here is that from here to here, what can you substitute? You can substitute easily 2m by m plus 1 from equation number 1. So here we can say that 2m by m plus 1 plus 2 by m plus 1 into m plus 2 is equal to 2 into m plus 1 divided by m plus 2. Now, our aim is here, you take LHS as we have taken in the first case, take LHS, simplify to some certain extent so that we could be able to get this particular RHS. If it is so, means it is proved. So, let us take LHS you take. In LHS, 2m by m plus 1 plus 2 by m plus 1 into m plus 2. Now, in the denominator, what is the most common term? Your most common term is 1 by m plus 1. And what is left over? Rather 2 also common, so you can take 2 by m plus 1. So here left over only m, and here left over how much? M plus 2. Can it be 2 by m plus 1 into m square plus 2m plus 1 divided by m plus 2? Can you further write 2 by m plus 1 into m plus 1 whole square by m plus 2? One of the m plus 1 cancel and left over 2 into m plus 1 divided by m plus 2, which is equal to RHS. This was your RHS, and hence we can say, therefore, Pn is true for n is equal to m plus 1, and hence we can say after that, therefore the series whatever it is given, therefore 1 plus 1 by 1 plus 2 plus 1 by 1 plus 2 plus 3 plus dot 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 1 by 1 plus 2 plus 3 plus n is equal to 2n by n plus 1, and that was to be. So understood? Understood? Now in this case what will you do? So many questions are there. In my next video, few other type of questions I will discuss, individuality also, and in this case also. Thank you so much.